Okay, I think folks are back now. If you didn't finish, that's okay. If you can just submit what you have. The main point is that I'm seeing that you try. I think we'll kind of go over things again together, so I don't think you will be missing anything. I don't need to see that it's completed, I just need to see that you tried. So don't worry about not getting participation points if you didn't finish, but hopefully people were able to get most of the way through. Okay, so what you should have noticed is that the thing that was causing the seasons in that simulation wasn't necessarily the distance between the Earth and the sun, but the tilt of the Earth's pole as it traveled around the sun. And so that's kind of what we're seeing here. The Earth is not the North Pole is not straight up, so as the Earth orbits, it's not staying up and down with respect to sun, it's tilted. So we're kind of orbiting in a weird thing. I do this with little kids and they love it when I jump around and I'm silly. It's harder to see when you just have a little square of me. But the idea is that the seasons are caused by that tilt of the Earth and not getting closer or further away from the sun. So we're just getting more direct light from the sun or less direct light, depending on if we're leaning towards the sun or leaning away from the sun. And the other way that I like to remember this is that seasons are kind of flipped if you change your hemisphere. So while it's summer in the northern hemisphere, so for most of us, I think, in the US, it'll be summer. It's winter in the southern hemisphere. So for South America, for Australia, our seasons are flipped, which is really great if you want to get away from the cold and you can go to Australia in February. Highly recommend it. It's a really cool thing about science. You get to travel a lot, which is fun. But that being said, so that's the way I like to remind myself, is that if it was because we were getting closer or further from the sun, the entire Earth would experience seasons in the same way. But that's not what's going on. It's that tilt. And because it's a tilt, it changes depending on what hemisphere you're in. So seasons are kind of flipped. The one time that was not, the one time where all hemispheres are experiencing the same thing, or both hemispheres, there's only two, is during those equinoxes. So the spring and autumn equinox, or the vernal and autumnal equinox, is when everywhere on Earth, so that degree tilt doesn't really matter, everywhere on Earth experiences a 12 hours of sun and 12 hours of dark. The other thing I was kind of joking with one of the groups is that this kind of whole tilt thing is why there was that horror movie, I didn't actually watch it, so I can't talk too much about it, that came out midsummer, where they have the first day where the sun never sets in the northern hemisphere near the pole, and so they go through and you have craziness because the sun never sets and you can't sleep because it's never dark. And that's because of the tilt of the Earth. And if you're high enough, if you're in that 23 degrees from the North Pole latitude, you will experience a full 24 hours without a sunset. And that sounds miserable to me. I like to sleep in the dark. Did anyone have any questions that came up while you were working on that activity? Okay. So this is just another way to see that. We've got kind of a tilt. So you don't have a poll for this. This would be summer, since our summer in the northern hemisphere, because the northern hemisphere is tilted towards the sun, the southern hemisphere is tilted away. The Tropic of Cancer and the Tropic of Capricorn are 23 degrees from the equator, and so those are kind of where your seasons are less extreme, because you're always getting fairly direct light because the tilt of the Earth is less of an issue. Walla Walla is at about 45 degrees latitude, so we're above that Tropic of Cancer, so we get more extreme seasons because we're higher. Closer to the equator, you get less extreme seasons. Higher up or down, you get more extreme seasons because you're experiencing the tilt more. Another thing I like to point out, that again, this is a very common misconception. The seasons are not happening because we're getting further or closer to the sun. It's happening because of that tilt. So something in your reading from last night, they talked about how all the planets are traveling on elliptical orbits, so not circular, slightly oval. And that's true. We are getting slightly further and closer to the sun, but not enough for it to really matter. So that's not what's changing the seasons. It's that directness of the light. And one way I like to remind myself of this is that the sun, Earth is actually closest to the sun on January 3rd. So for all of us in the northern hemisphere, if it was that closest to the sun thing, we would expect summer to be in January and not in July, when the sun is actually, when the Earth is furthest from the sun, when we're at aphelion. So we'll talk about that a little bit more, what those words mean. But just to point out that, again, seasons are caused not by getting closer or further to the sun, but because of the directness of the sun rays. So that tilt of the Earth is what determines our season's length. And this is true for other planets as well. What determines how seasons behave has to do with the tilt of that planet. So the inclination is kind of the official word, but tilt is fine too. So to see how we're all doing, I'm gonna send you guys a new poll. Just asking on this image, which of the points is going to show the summer solstice in the northern hemisphere? A few people have voted. There are 6 more or 5 more people. We can get 2 more votes. Okay. So we are mostly getting it right. We're about 50% right. It's a little tricky to tell, but C is going to be the right answer because we're leaning in towards the sun. So the northern hemisphere is leaning in towards the sun at point C. It's a little confusing on this picture. Point A, you can also see that tilt really matters, but at that point, the northern hemisphere is leaning away from the sun. So that's actually going to be winter. We want to see the northern hemisphere leaning towards the sun, getting that direct sunlight. If A and B are our solstices, what are, or A and C are our solstices, what are D and C? I've also got my chat open. If someone wants to yell it out, or they can put it in the chat.
Equinoxes?
Yep, those are our equinoxes. So equinoxes equal, everywhere's experiencing that same day. Kind of, maybe that's like a little helpful mnemonic. I have one more poll question. So finally, we're going to think about this. Like I said, kind of that tilt that's changing the season. So with that information, sorry, I lost my poll button. Which one of these planets is going to have the most extreme seasons? I'm a giant nerd, so I tried to get some fun planet names.
Okay, but like, what's Arrakis? Hoth is Star.
Arrakis?
Yeah.
So
Vulcan.
Arrakis, sorry.
Sorry, I'm just like, Hoth is Star Wars.
Yep.
Like, can't get the other two. Vulcan would be like.
Vulcan is Star Trek.
That's what I was gonna put, like.
Live long and prosper. So Arrakis, does anyone know? That one's a little bit more.
It's Dune. I read it this summer.
So I think Dune. So there's a pretty famous sci-fi book called Dune that takes place on the planet Arrakis. And I tried to kind of get these to make sort of sense. So like Arrakis is a desert planet, so it's closer to its sun, and Hoth is a winter planet, so it's further from its sun. Sorry, you guys are seeing how much of a nerd I am. And you all voted. That was a good way for us to get through everyone voting. So pretty much everyone said Vulcan, which is right on. Vulcan has that biggest tilt, 30 degrees, slightly more than Earth. So it will actually experience seasons as it travels around its sun. I'm not actually, I should know the names of the stars in Star Trek. And then Arrakis won't have much of seasons at all because it just has a 5-degree tilt. So it'll pretty much, everyone will be getting a similar amount of light, directness of light throughout this year.
I have a quick question about the seasons. So if any planet is at a more extreme tilt than Earth, would the seasons be too extreme for humans to live through?
That's a good question. It kind of depends. It's going to depend more on where that planet is with respect to the sun than how the seasons are changing. We'll get to this more when we talk about the giant planets, but Uranus is actually at a 90-degree tilt. So it'll have, you know, for its northern hemisphere will have like all light all the time, half its year, and then its southern hemisphere will have all dark all the time, half its year. So that would suck to live there, but that's not the reason why humans can't live there. The reason why humans can't live there is because it doesn't have solid ground and it's way, way out in the solar system, so it's not getting enough light, period. So seasons probably aren't super necessary to life.